All right, 11.1 and 11.2. We're talking about two lessons today, but we're not doing all of 11.1, so that's why this is an abbreviated version. We're talking about matrices. Matrices is another way to solve equations. I did this last period, and a couple of people said, oh, this was just on the ACT. I didn't know how to do it. Well, maybe if you guys see it again, you'll be able to do it. But a matrix is just a different way to represent a system of equations. We are not going to go through the whole process of solving systems of equations using matrices. It's a really involved process that we're not going to get into. But I do want to introduce you guys to the concept of what a matrix is, how to add them and subtract them, multiply them, that sort of thing. So it says the definition of a matrix, M and N are positive integers, and it's read M by N. Notice that. A matrix is a rectangular array of numbers. All right, you're going to see a bunch of numbers in these little bracket things. Left to right is called a row. Think about a row at a movie theater. Up and down is a column. Think about a column in front of a house. Okay, each little number is called an entry. So what I want you guys to get from this is we're going to be asked to name the dimensions of a matrix. The way that you name the dimension of a matrix is you name the row by the column. So you look left and right, just like you would on an XY chart, right? If you're at the origin, you go left and right first, and you go up and down. So a row is left and right, and a column is up and down. Now, in 1 second, that'll make a ton of sense. But when you are asked to name the order or the dimensions of a matrix, it's just left to right and up and down. There's no work to be done or anything like that. It's just naming something. I'll show you in a second. If you are asked to name the order, another way to say this is dimension, you count how many rows are there and how many columns are there. So if I look left to right, how many rows are there? 1. By how many columns are there up and down? 1. That is a 1 by 1. Literally that easy, I promise you. Look at B. It's left to right, up and down. Think about X and Y. So how many rows across is this matrix? 1. By how many columns are there? 1, 2, 3, 4. It's a 1 by 4. I already made your quizzes. There's a question on the quiz. It says, name the dimensions of this matrix. If you get that wrong, that's on you guys. How do you name the dimensions? Left to right, up and down. So letter C is a what? It's a 2 by 2. How many rows are there? So you're looking left to right. By how many columns are there? You're looking up and down. Does that make sense? Look at D. How many rows are there in D? 1, 2, 3. By how many up and downs do we have? 2. That's a 3 by 2. Questions? We good? All right, let's look at the next slide. Now you guys are like, oh, geez, you always say it's easy, and then you go. Okay, let's look at this. Do you guys see this system of equations right here that I'm going to circle in red? Everybody sees the system of equations. What variables do you see? What are they? I see x's, I see y's, I see z's. I see a hole right here. What does that represent? That there's no y, right? I want you to compare the system of equations that I circled to where it says over here, the augmented matrix. Just look at those two. What do you notice? I know it's small. Just zoom in on it. It's the same. What is it just missing? The letters, right? When they tell you, given this system of equations, write the augmented matrix, guys, all they want are the coefficients and the answers. That's it. Do you notice how the x column, if I look up and down, the coefficients are 1, -1, 2, right? What is it here? 1, -1, 2. What's the coefficients of y? -4, 3, and 0? Look at the y column, -4, 3, 0. Does everybody see that? What is the coefficient matrix? How would you describe that compared to the system of equation matrix, or the systems of equations that's circled? It's just the numbers in front of the variables without the answers. All right, does that make sense? That's 2 quiz questions right there. You're going to have a question that looks like this. It might say, write the systems of equations given the matrix below, or given the system of equations, write the matrix. So in this first example, what are you given? You're given the system, so what do you need to write? The matrix. So Guys, just so you don't make silly mistakes, what 3 letters do you see represented in the system of equations? I see an X, I see a Y, and I see a Z. At least one equation has one of those variables. So make yourself columns so you can see. So my X coefficients go first. What are the X coefficients? -3, 4, and what? 1. Perfect. If you want to go left to right, let's just do the first equation. What's the coefficient of X? -3. What's the coefficient of Y?
0.
0, because there isn't one. What's the coefficient of Z? 5. And then what's the answer? 9. What about the second equation? Coefficient of X is 4. What's the coefficient of Y? -3. What's the coefficient of Z? 15. What's the answer? 1. Look at the last equation. What's the coefficient of X? 1. What's the coefficient of Y? 6. What's the coefficient of Z?
0.
There isn't one, so you have 0. And then what's the answer? -5. Now, somebody last period, if you want to leave it just like that, that's fine. If you want to separate the answers, excuse me, from the variables, you can either do like the little colon like they did in the example, or if you want to just do like a straight line like that, that's fine. Don't put an equal sign inside of a matrix. But if they give you the system of equations, just write all the coefficients with the answers. Just make sure if there isn't a variable represented that you have something that represents it, right?
Where is?
Huh?
I don't spell it.
Now, if you look at the next one, I wrote this one in. You guys take a picture of it, whatever. But it says, okay, here's the matrix. Write the system of equations. Well, before you do this, just so you don't make a silly mistake, guys, what letter do you start with? X, Y, Z, and what are these? The answers. So if you were going to write the system of equations, what does the first equation say? -3x plus 4z. If you want to write the 0 to make yourself feel better that you have everything represented, do that. -3x plus 0y plus 4z equals 7. If you don't want to write the 0, you don't have to. So my next equation says 0x plus 7y plus 4z equals what? -1. Good. And then what's the last one say? -x plus 5y plus 12z equals what? 0. Yes, ma'am. No, you don't have it. Does either way. You could leave it. You could just write, if you want that first one, -3x plus 4z if you want. You could write it to where there's a big gap, but there's nothing there. That's fine. Just, I know some people don't like, they like to have every little piece represented, which is totally cool.
Can you go up?
Sure. All right, does anybody have any questions about that first part? The biggest thing to remember is how, I'll explain it in a minute. You'll see it again. If I asked you right now, here we'll go over it now. If I asked you, given this system of equations matrix, what are the dimensions? How do you name the dimensions of this matrix? It's a row, so how many rows are there? 3. By column, how many columns are there?
4.
This is a 3 by 4. You name matrices, row, excuse me, it always goes left and right. How many left and rights are there? By how many up and downs? All right, so now we're going to go to adding and subtracting, and we're going to do something called scalar multiplication. It's really scary. It'll take me about 3 seconds. All right, this slide says a lot, but really and truly what the most important thing is right here that I already wrote for you, and I want you to highlight it. It says adding and subtracting. In order to be able to add or subtract, the dimensions have to be what? The same. Meaning, if you're going to add matrices together, it has to be a 3 by 3 plus a 3 by 3. Or a 2 by 3 minus a 2 by 3. The dimensions have to be the same. Very important to remember. So if you look at something like this, before you add them, because there's going to be some on WebAssign that's going to say, oh, wait, you can't do it. Impossible. Check the dimensions. What are the dimensions of the first matrix? It's a 2 by 2. There's 2 rows by 2 columns. What are the dimensions of the second matrix? It's a 2 by 2. Since they are the same, you can add them. Question? All right, so this is how we do it. This is how easy it is. You take the top left from one of them with the top left of the other one. What's -1 plus 1? 0. Okay? Now, it doesn't matter if you go left or right, up and down. But I'm going to just go here. I'm going to say top right with top right. What's 2 plus 3? Okay. Now I'm going to say bottom left with bottom left. What's 0 plus negative 1? And then bottom right, what's 1 plus 2? And there's your answer. That's why the dimensions have to be the same, because you add or subtract the corresponding parts. If you had 25 numbers in there, it doesn't matter. The top middle of the left one goes with the top middle of the right one. So if you're taking a matrix like this, could you add these two together? How come? They're the same. They're both the 2 by 3. But what do you notice you're adding? You're adding nothing. You're adding 0. So when all this is going to be is just this. Can you add this one together? Yeah. This is a 3 by 1 plus a 3 by 1. So what's 1 plus negative 1? 0. What's negative 3 and positive 3? 0. What's negative 2 and positive 2? 0. All right. That's fine. Yeah, that's what tells you it's a matrix. All right. Let's add these two together. Can you?
No.
Why? Watch. This is how you would show me this on a quiz. This is exactly how you'd show me your work. What are the dimensions of the first one? It's a 3 by 3. What are the dimensions of the second one? A 3 by 2. That's you showing me, oh, wait, it doesn't work. And then you could write this. This is what they ask you to write on WebSign. Well, I think sometimes some questions might say DNE, meaning does not exist. Just read the directions. Yes, ma'am.
So is it possible because there's no question?
No, it's impossible to add them because the dimensions aren't the same. Because when you're adding, that you add corresponding entries. So like top left would go with top left, correct? Then this middle would go with this middle. But then this poor 0 has nothing to combine with. So they have to have corresponding parts. That's what adding and subtracting. Does that make sense? Okay. Then you get to a question like this. This is not a hard question, guys. They'll give you, excuse me, they'll give you some sort of an equation that involves matrices, and it says solve for x. So the first thing you should do is solve that equation, just like you would, back in the days of in the 8th grade. How would you solve this? To get x by itself, what would you do?
Subtract it.
Okay, subtract a. Good. So 3x equals b minus a. Then what? You divide by 3. Perfect. So x equals matrix b minus a over 3. What's another way? You don't have to do this. I just like to do this. What is another way? Instead of saying divided by 3, what's another way I could write that? I could times it by what? I could times it by 1/3. I'll show you why I like to do that. You do not have, you can keep it as divided by 3 if you want. So in order to figure out actually what x equals, what do we have to do? You have to subtract b minus a, right? And then divide everything in it by 3, or multiply everything in it by 1/3. So pay attention to the order. Which matrix am I writing first? B. So write down your B matrix. It's -4, 6, -5, and 0, right? Everybody agree?
Yeah.
Minus, what's your A?
How did you write B?
Because that's when we solved for x, it's B minus A.
So whenever you get the answer, you just divide by.
Correct.
So what's the third one?
It's the next thing we have to do. We're solving an equation. So I have 7, I don't know why I wrote that. Hold on. Yeah. So it's 7, 2, excuse me, -3 and 1, right? And when we're done with this, we're either going to multiply everything inside by 1/3 or divide by 3, however you guys want to look at it. Now, you're subtracting. The same way we added, we subtracted. We can do this because it's a 2 by 2. So you could say negative, right? Don't you guys see that -4 goes with 7? So you could say -4 minus 7, -5 minus a -3. I don't like when there's a minus sign in the middle because a lot of times we miss signs. So I like to go ahead when I have any subtraction. I like to change this to a plus and then do what to all the signs behind it? Just change all the signs. That way you guys don't get stuck on I minused a negative so it became a positive. Don't get stuck on that. Just go ahead and make your life easier. So now when you add these two together, what's negative 4 plus a negative 7? Negative 11. Everybody with me? Okay, so now I'm going to come over here. Negative 5 plus 3. Perfect. Now I'm going to say 6 plus negative 2.
4.
Perfect. And then I'm going to say 0, excuse me, plus negative 1. Negative 1. Now, in this case, if you kept it as divided by 3, it would look like this. Negative 11, 4, negative 2, negative 1, and then you had divided by 3, right? All that's saying is everything, every single entry in your matrix, you need to do what? Divided by 3. If it doesn't divide pretty, leave it as a fraction. So your answer would be what? What would my answer look like? Negative 11 over 3. What else? Negative 2 over 3. What else? 4 over 3. And negative 1/3. These two things are the exact same thing. I just like to look at it as I'm distributing a negative 1/3 rather than dividing everything by 3, but it's the same thing.
So that's our answer?
Yep, this should be your answer. You added them or subtracted them, add the opposite, and then divide it.
Are we gonna do it where like you multiply the matrices?
All right, right now, guys, if I gave you your quiz, you would know how to do 60% of it. Yeah. We're going to learn one more thing now and one tiny little concept Monday, and then you guys are ready for your quiz. This is going to be easy, I promise you. Even if you're not paying attention now, if you go home and watch this weekend and just practice your WebAssign. I gave you the WebAssign. I did not make it due until Wednesday. But you should try and do it over the weekend so you can come in here and say, hey, I have a question about this. How did this happen? Something like that. All right, let's look at the next. Oops. All right, now we're going to talk about some multiplication stuff. When you see scalar multiplication, all that means to do is distribute. Do we know how to distribute? All right, let's look at these problems. What do you think, an asterisk number 1, what do I do with that negative 4?
Apply it to the rest.
I distribute it to what? Everything. All it is 6 multiplication problems. What's negative 4 times 9? Negative 36. What's negative 4 times 7? What is negative 4 times negative 1? 4. Just be careful with your signs, guys. What's negative 4 and 6? Negative 24. What's negative 4 and negative 4? 16. What's negative 4 and 8? That is it. All right, what do I do with this 1/2? I distribute it. Guys, multiplying by 1/2 is the same as dividing by what? 2. Okay, so if I say 1/2 times 1, what does that give me? 1/2. If I say 1/2 times negative 3, what does that give me? Negative 3 over 2. If I say 1/2 times 5, what does that give me? 5 over 2. And if I say 1/2 times 1, 1/2. Does that make sense? Okay, good job. Very good. Super duper important. I just said, are we going to multiply these two together? Of all the words, blah, 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 blah. You see what I wrote? That's what's the most important. In order to multiply, the inside dimensions have to be the same. Now, with adding, all of the dimensions have to be the same, right? If you are multiplying, do you see how here, these are just examples. Do you see how I wrote down? Say we had a 3 by 2 times a 2 by 3. If the numbers in the middle are the same, you can multiply. And the outside numbers tell you what your answer structure is. And I'll go over this. If you look here, the second one, a 2 by 3 and a 3 by 2, you could not add those together because the dimensions are the same. But you can multiply because the inside numbers are the same. If you look at the last example I wrote down, a 1 by 2 and a 1 by 2, do you see how the two middle numbers are not the same? Then you cannot multiply them. Multiplication is a little different from addition. So if we look at a question like this, it says find the product of A and B. Product means multiply. And then the bottom one says find the product of B and A. Well, guys, multiplication that we're used to. What is 3 times 2? 6, right? Well, what's 2 times 3? Still 6. This isn't normal multiplication where we're just multiplying a number times another number. We're multiplying a set of numbers times another set. So in this case, order's going to matter. And I'll show you why. So I'm finding the product. I'm going to multiply A times B. In order to know if you can do this, you have to have the dimensions first. So what are the dimensions of A? It's a 3 row by 2 columns. Everybody agree with me? What are the dimensions of B? It's a 2 by 2. When you're multiplying, what matters? The inside. Are those two numbers the same? So can you multiply them? Yes, and your answer is going to be structured like this, a 3 by 2. To this day, when I write answer keys and stuff like that, I do exactly what I'm doing right now, I do on my paper because it makes your life so much easier. Because it's hard to envision what you mean your answer is going to look like. Write it down. It's going to be a 3 by 2. What does that mean? What does that mean, a 3 by 2? 3 what? What goes first, rows or columns, guys? So it's going to be 3 rows by what? 2 columns. So it's going to look like this. 3 rows, 2 columns. Does that make sense? Do you guys understand? Okay, so let me show you why this is so unbelievably important. You're going to multiply A times B. So I'm going to write down the A matrix. Hey, make sure my signs are right. -1, 4, and 5. And then 3, -2, 0. And then my B is -3, -4, 2, and 1. Did I write everything correctly? All right, now, again, you do not have to do this, but I'm telling you this will make your life so much easier. The reason I write out what my answer should look like is it's like a roadmap for me to figure out what is going where. I want to find this entry right there. Where is that located? What row and what column? Is that in the 3rd row and the 2nd column? No, it's in what? First row, first column. So that's where we're looking. We're looking here, the 1st row and the 1st column. This is how you figure out what you're combining. You take 1st row, 1st column. So I look at the 1st row and the 1st column. Multiply the two numbers together. What's -1 in the 1st row times -3 in the 1st column? 3. And I add that to 2nd times 2nd. What's 3 times -4? And then add those together. We're going to do, hold on. I went 1st row, 1st column. So in the 1st row, my first two numbers here are -1, -3, right? Multiply them together. And then I add it to 3 times -4. That's how you get your first entry. Once I do a couple of these, you guys will be all right. What's 3 plus -12? -9. All right, we found that first piece right there. So now I'm going to say, okay, this is what I'm looking for right now. Bella, tell me where that X is located that I just circled. First what? First row and the 2nd column. So the two numbers I'm looking at are, what's the first number in the 1st row and the first number in the 2nd column? What's -1 times 2? Bella, -1 times 2. -2 plus the second ones. What's 3 times 1? What's -2 plus 3? +1. There you go. All right, let's look at the next one. I'll do a highlighter. I want to find this piece right here. All right, I'm talking to Heaven. Where is that blue dot located?
4.
Okay, but what row, what column? Tell me.
1st row, 2nd
No,
row.
it's the 2nd row, 1st column. Do you see the numbers that I'm talking about? They're highlighted in blue. This is helpful if you guys have highlighters. I'm looking at 2nd row, 1st column. Those are the numbers that we're dealing with right now. So I take the first two numbers. What's 4 times -3? -12. And I add it to the second two. What's -2 times -4? Yep. So what's -12 plus 8? -4. Okay, you're doing the next one. It's very helpful to have colors. I want that one right there. Tell me, kiddo, where is that one located? You do it. You got it. Tell me, where is that located? What row?
Second row.
Second row. What column? Second column. So now do you see the numbers that you're looking at? I'm looking at 4 times 2. 8 plus -2 times 1. What's 8 plus -2? Perfect. All right, kiddo, you're staying with me. I'm picking on you for a good reason. I want that one right there.
Third row.
Third row. First column. Do you see the numbers that you're looking at now? 5, 0, and -3, 4. You take the first two, multiply them together. 5 times -3. -15. And you add it to the second ones multiplied together. What's, oh, bad color choice, sorry. What's 0 times -4? So what's -15 plus 0? Yep. Last one, you're going to finish it off. I want that one right there. Where is that located? Third row, second column. Do you see the numbers that you're dealing with? Where'd you get 10 from? Perfect. 5 times 2 is 10, plus, which is, good. The best thing to do with these, it's much easier on Notability, because you can highlight and then erase it. But it's on paper, it's best to have colored pencils or a highlighter. It makes your life much easier. But it's just practice, guys. But if you give yourself this little, like, oh, that's where I'm looking, it'll make your life easier, I promise. Now, let's look at the second one. The second one says find the product of B times A. So you guys are like, well, I mean, we just did that. Write down the dimensions of B. What are the dimensions of B? It's a 2 by 2. So I'd write 2 by 2. And then what are the dimensions of A? It's a 3 by 2. Can I multiply these two together? No, why not? Because the inside dimensions are the same. You would tell me in this case this is impossible. You will probably have something like that on a quiz. You'll definitely have it on your web assign. That is how you show me, oh, they understand they can't multiply them together. You don't have to write a paragraph to tell me why. Just be like, oh, look, the dimensions aren't the same. Let's do one more. Copy this down. All right, can we multiply, can we multiply these two together? I don't know yet. How do I know? What are the dimensions of the first matrix? It's a 2 by 3. Perfect. Row by column. What is the dimension, or what are the dimensions of the second matrix? It's a 3 by 2. Can I multiply these two lovely things together? Yes. What are the dimensions of my answer going to be? A 2 by 2. What? How in the world is this going to be a 2 by 2? So it's going to look like this. 2 rows by 2 columns. You guys see that? All right, so let's take our time, draw ourselves a little roadmap. We know what we're trying to find. I'm picking on you guys for the best reason possible. Don't be mad at me. Heaven, where is that X? First row, first column. So you're going to multiply and add. So the first two numbers, multiply them. What are the first two numbers in the row and the column? 2 and 1. So 2 times 1 is? 2. Perfect. Then you're going to say plus. Then you multiply the second two together. -2. What's the second number in the? Yep, so -2. You have? No, what's the second number?
2.
No, the second number.
1 and 2.
What kind of 1 is that? -1. And 2 is? -2. Good. Now the third one's together.
-12.
Yep. So add all those together. What happens with 2 and -2? They cancel, so this is just -12. All right, I'm going to leave you off the hook. Bella. I want that one. Tell me where that's located. And if you guys get it wrong, who cares? We're just going through it. Where is that yellow dot located?
In the first row.
First row. Where?
Second
Second column. So we're going to multiply first times first, second times second, third times third, and add them together. So what are the first two numbers you're going to multiply together? What?
4 and 2.
Which is?
8.
Perfect. Plus.
-5 and -1.
Perfect. Plus.
And then 6 times 4.
Which is?
24.
Perfect. And then we add them together. What's 13 plus 24?
37.
37. Wonderful. All right, boys. My girls are doing well. Let's pay attention here. Gus, you're going along with me. I want to find that piece right there. Where's that located?
The
Second row, first column. Do you see the numbers that you're dealing with?
Yeah.
Okay, tell me what they are.
7.
7 times 1 is
7.
perfect.
-4.
Positive 2 and negative 2 gives us -4.
And then
And then 5, -3 gives you a -15. If you want to write minus, that's fine. I'm just showing it's adding. So 7 minus 4 is 3, minus 15 is
-2.
perfecto. Heaven. I'm not going to call on the people who aren't even paying attention. That'll become evident when they either take the quiz and don't do well or just don't take it. Heaven. I'm picking on you for a good reason. I want the pink one. Where's the pink? Where's the pink one?
Second row,
Second row, second column. You see those numbers you're dealing with?
Wait, it's second column.
Did I not highlight it? Oh, thank you. Right here. Okay, you see those numbers? All right, kiddo.
So 28,
7 times 4 is 28. Good.
10,
-2 and -5 is 10, and perfect. 28 plus 10 is 38, plus 30 is 68. And there, ladies and gents, is your answer. Now, once you do a couple more of these, you get the hang of it. But it's very helpful. It's very, very helpful to have some sort of color system, whether it be color pencils, highlighters, that sort of thing. Sound good? All right.